to the first Kubernetes Cloud Native online meetup. This session will be recorded, so don't say anything stupid if you don't want to be in the internet. To the background, we thought we need a platform for the community to share the good ideas. We had the local meetups here. We had several events in Germany, in Europe, but this is a global thing, I would say. So we thought, why not share the ideas via a meetup, so we can go in some topics like new releases, some live streams of events, or some user use cases from users. So this was the idea behind. So we started this some weeks ago, and it's growing quite fast. So I hope this will the pace of will be steady, and we will have a big meetup in the next months, and have good topics. So David is joining today and giving us some updates about the last year. So last week was the first birthday of Kubernetes, and I think it was a interesting year, and he will give us a short recap. And then he will give us some news about the new version, and probably some review and preview on what will happen in the future. So David, it's your stage, and thank you.
Thank you very much for the opportunity. And like you said, I can't stress enough how much this is a global community. While I happen to work at Google, on Kubernetes, this is very much not a Google-only product. It is a community product, first and foremost. And it's been just absolutely incredible to see the kind of uptake that we've had from people all over the world. Every day I get a new notice about somebody in a new country spinning something up. They tell me some crazy new deployment they have, contributions to the core product, and taking Kubernetes in a bunch of interesting directions. But with that, before we look to the future, I thought it might be very interesting to look to the past and see how things came about. As many people know, Google has been developing and using containers internally for about 12 years. At Google, literally everything runs inside a container. Every database, every web query, every Gmail, every blob store, even VMs at Google run inside containers. And so we are completely bought in on it, but it took us a long time to get here. In 2002, when we first got things going, we had these application-specific machine pools. So obviously Gmail wasn't live at the time, but you might have an ad-based machine pool. You might have a query-based machine pool, a MapReduce-based machine pool, each of which would have lines drawn around it about exactly what could run on it. But the problem is that this was incredibly painful to manage. And so we leapt to going to shared machines. And we tried to use the tools that were available at the time, which were things like chroots, ulimits, using nice and things like that. But the level of isolation really wasn't there. You had things like noisy neighbors that really caused a lot of problems and made it very pernicious to try and debug what was going on any given machine. And especially as the fleet got larger, the utilization, which was not great at the time, got worse. So, you might add another 10 machines, but that was because the utilization was so low, that was in essence the effect of adding one or maybe two machines to your fleet versus actually the full 10. So in 2006, Googlers were some of the first people to contribute upstream to the Linux kernel, C groups. And this gave you detailed resource isolation for things like CPU and memory. And it enabled much, much better sharing and much higher utilization. For us, the key was that isolation. Like, how do you take a single machine and shard it in a way so that you can have these very detailed breakups of your workloads into these microservices, and let people adopt them without thinking about what else is running on those machines. The idea of namespacing was somewhat secondary because we were all Google, and we knew, we could track down the developer who checked in a bit of code and who was violating a certain set of things. You can actually see the container work that we did at that GitHub account. It was called Let Me Container That For You. And it was our open source release of some of the stuff that we do internally. But, that was very good for us. As far as for the marketplace as a whole, there was a lot more to be done. We made plenty of mistakes while launching it and bringing it to production, and we learned a whole bunch. And in 2013, Docker caught fire. And, we have to give enormous credit to them for really taking what was an internal developer tool, or certainly fairly arcane, and brought containers as a packaging system to everyone. The ability to namespace, the ability to run everywhere, and have these workloads be very portable was extremely powerful. But internally to Google, when we approached containers, almost simultaneously with that, we went and implemented what was called Borg. Borg was our internal productionized version of how to run containers. So you would spread those workloads across all those various machines, but then you would need something to handle all the things when it came to production. How do you aggregate logs? How do you do service discovery? How do you do load balancing? How do you mount configs in? How do you handle secrets? All these various things. Over the past, 10 years, we've put a ton of work and mental energy into that, gone through a number of revisions of Borg. And when Docker came out, we knew that folks were going to need to go down the Docker path, or down the Borg path in order to run in production. Whether or not it was our orchestrator or someone else's, these problems were going to have to be solved. And so in the spirit of, bringing the work that we had done to the world, we introduced Kubernetes. So Kubernetes, for those that don't know, it's the Greek for helmsman, and also, very interestingly, the root of the words governor and cybernetic, which I think is really, really cool. But it basically was 100% concept only, almost a clean room rewrite of Borg in open source Go. It was 100% done in open source. We checked in every line of code from day one into GitHub. And while it's based on the learnings that we had, it's actually even better in many ways than our internal version. And I'll get to some of the ways that we improved the way that we did internally. Part of the core philosophy of Kubernetes, is that it runs everywhere. So it runs on multiple clouds. It runs on your laptop. It runs on VMware. It runs on Mesosphere. It runs on AWS, and DigitalOcean, and OpenStack, as you saw a lot of the news today. We want it to be a generalized solution for providing container orchestration, for letting you bring your workloads to production. And that last bullet is really probably the most important, which is we want to allow people to manage applications and not machines. So I mentioned earlier some of the core decisions that we made when moving things over. These are core philosophy things, some of which were learned from running on top of Borg and managing our own platform for so many years. Some are just better architecture decisions that we can make the third or fourth time around. The first, as I mentioned, no lock-in. Kubernetes must be able to run everywhere. That is a core philosophy, and we consider it a P0, P1 bug if something breaks on a particular cloud or in a particular configuration. It's incredibly important. Not everyone is ready to go cloud native, but we can help you run in a containerized, cloud-native way, no matter where you are. Second is portability. You should be able to take your workload and run them anywhere and have general abstraction from the underlying cloud and Kubernetes concepts. So when you spin up a particular workload, all you're saying to Kubernetes is, I need this much disk in a persistent volume. I need this many replicas. I need to use this environment variables, and Kubernetes will figure that out. If you wanted to take that and run that on another orchestrator or run that on another cloud, by and large, that should be a one-to-one mapping for you. These are not unique Kubernetes concepts where you're writing a detailed construction on how to run your applications and run your containers. We take care of that for you. The third is pods, not containers. This is something that we learned very deeply internally. We actually don't have this concept, but what we found time and again was that containers, a single container, to have it be a microservice is critical, that it has additional agents and additional things that take care of things. So while your app may only just respond to a web request, you need something to do log shipping. You need something to do auditing. You need something to do security. You need something to do, to mount in or copy in a particular disk or check a web service on a daily basis and pull down a set of content. All of that stuff is not directly associated with your application. Your application consumes or depends on that, but those are separate. And the best practice is to break those out into their own containers. Now, that said, you think about them as a holistic, hermetically sealed ball of stuff in order to run your application, and that's why we provided pods, so that you can do that, so you can schedule all those together, but still get the benefits of microservices and containerized isolation. IP per pod. One of the biggest challenges we have, even still internally, is the fact that we do port brokering. It means that, it means that you need to think about what other containers are running on the same node you are, whether or not that port has already been taken, what ports are available. Once something dies, how do you alert the central port brokering system that you're no longer there, or does it check regularly? We said that all that's madness. We want to handle that for you, and so we're going to give you a cluster level IP address that is unique. You can have any port you want in the space, and Kubernetes will take care of it for you. The next is around logical views. If you're like me, you saw way too many VMs named US_app_frontier_V_2_3_staging. That's crazy. We wanted to give people the ability to logically name, logically address all of their containers and pods and resources in the system. And through that, we have a very rich labeling and selector system, so that you can take action on the system based on things that make sense to you. And finally, we're 12-factor by default, is what I like to say. Apps can configure themselves with secrets, with config maps, with persistent volumes, based on the environment that they're running in, with no special gymnastics. All you do is you ask Kubernetes to give you, based on the namespace, whatever you need, and your app will go up and running, or it will die because it's not responding to the health check properly, or it hasn't been load balanced properly, or whatever. It will automatically do it. So that the apps that are out there are running and healthy. So these are just a few of the core decisions that we made as part of the architecture of Kubernetes. And there's still lots to go as far as continuing to advance the platform and making it great for running whatever your container workloads are. But we feel like we've made great progress against all these. Just as a quick summary of the progress that we've made, it's an open source product, so we hear a lot of people using it in a lot of different ways, but we don't know everything everywhere. And so for better or worse, we consider the most important thing is how many people are contributing. And as you can see, just recently we crossed 30,000 total commits to the project. Another 4,000 commits in the 1.3 timeframe, which was just about 3 months. with 40% more unique contributors. We're top 0.001% of all GitHub projects. I think we're number 173 or something like that in total number of stars, and thousands of external projects based on Kubernetes. So, this is very much a community thing. You could see just a few of the many companies that are contributing to Kubernetes, and many of the companies that are using it. We just couldn't be happier with how things have gone. And I think it's important to remind everyone and bring it back, what is our goal here? We want to give everyone the power to run agile, reliable, distributed systems at scale. Much in the way that people, for years came to Google and, a week after starting, they could spin up a workload on 25,000 machines without even thinking about it. We want to give that power to everyone. And it's important to note that I think that the Kubernetes project is really three things. The first is people, and I mention people over and over again. It's a set of committers, it's people using it, it's people talking about it and being evangelists or hearing from customers or users, problems, and really providing a very positive feedback loop. Everyone talks to everyone else and brings those things back into the company, the project. The second thing is really around enterprises. We at Google know how to run containers and have our own philosophy on it, but we really want to hear from lots of folks how they're using containers and Kubernetes, and really changing the way that they deploy. I mean, I can't tell you how many times you hear the statement that somebody had 6-month release cycle for something, and because they adopted containers and Kubernetes, they're now releasing multiple times per day. It's a really powerful thing, and enterprises really make that happen. But then finally, it's an ecosystem. And by ecosystem, I mean, there is opportunity for people out there to make lots of money. The Kubernetes project is not a business. I can't tell you that enough. We want it to be open source. We don't need to grow in order to make revenue or charge for support or anything like that. Our goal is to allow other people to make money in the ecosystem, and be very, build entire large businesses on top of it. That's extremely exciting for us. And all of that is based on the history that we had at Google. With over 10 years at this point of running containers, we feel like we have a pretty good background for, mistakes made and things that we can improve. And most importantly, literally tens of thousands of ex-Googlers out there in the world who love to talk about it and, want to do a bunch of things. Just a few things we've learned, and I'll be pretty quick here. The first is the easy stuff is easy, the hard stuff is hard. Getting started, you can do that incredibly trivially. In one click, you can get it running on Google Container Engine. You can get it running on Google Cloud or AWS or Rackspace with a single command line using the default script. But where the challenge starts to come in is when you start to customize, where you start to need, 1,000, 5,000, 10,000 nodes. You're going to need to make configurations. And one of the things that we're spending an enormous amount of time right now is allowing people, it's not just that getting started experience, which we always want to make better and easier, but it's really how do you allow people to have transparent visibility into how things are set up, and let them configure so that if you have a custom HA proxy that you've set up for manual load balancing, great. Here's how you integrate it. And there's really no shortcut to being production ready. In a lot of ways, it's just miles on the car in order to get things running. The second thing we learned is community is everything. I can't tell you how many times we've seen people bring things in, whether or not it's brand new setup scripts, running certificates, support for Docker Compose, support for functions running on functions as a service running on Kubernetes. I mentioned those 2,000 projects before that are based on Kubernetes in some way. That would only be possible with the evangelism and passion of thousands and thousands of people. And those thousands of deployments help us enormously. And we really want to give people feedback, or give people the opportunity to give us feedback to make the product better. And then finally, leveraging that is feeding the virtuous cycle. We consider it our measure of success is for the ability of other folks to make money, whether or not you're charging for support or building a great ISV software application or providing a hosted version of Kubernetes or 1,000 other things. We have very clear swim lanes for Kubernetes. We don't want to grow up. We don't want to grow down. We don't want to grow sideways. We want to stay in our, allowing people to run distributed applications and let other people fill in where it makes sense and where they bring real sophistication. And the way that we think we can do that is by allowing people to adopt more clusters equal more contributors equal more happy people, go to 10. So with all that, any questions before I give a brief overview of what's in Kubernetes 1.3? Okay.
Sounds good.
Oh, yeah. Okay. So in Kubernetes 1.3, there were many features that made it in. I'll only just highlight a few in the spirit of the time, but if you have any questions or comments, please let me know. There are basically three big themes that we wanted to touch on in Kubernetes 1.3. The first is improving enterprise deployments. As I mentioned, enterprises have very deep requirements when it comes to maximum workloads, auto scaling, which is now in, cross-cluster federated services, which I'll detail in just a little bit. Identity and authentication management. You may use Active Directory, you may use LDAP, you may use AWS IAM or Google Cloud IAM, and we support that natively in the product. We also support container standards, including Rocket, OCI, and CNI. We want to allow enterprises to run in the way that makes sense for them, rather than dictating, a single container or runtime standard. The second big area was around stateful application support. Not every application is cloud native, of course. Many run in what is jokingly referred to as PET configuration, where it expects to survive and last for a long time. There's nothing about a container, by the way, that is inherently short-lived, but there is something very fundamental about containers that are, that they can be reborn and recover very easily. And many applications require a little bit more help to do that, and I'll get to that in a second about what we provide. And then the third is a great local developer experience. While spinning up a cloud cluster is very easy, it can be a little challenging to do so on your local desktop. And with some great work from the community, we have a fantastic local developer experience that I'll share with you. So diving into a few of those, a big problem today is cross-cluster federation. So it is totally normal to want to be on multiple clouds or be in multiple zones or split your on-prem and cloud deployments. And when you're setting up those various clusters, unfortunately, you have to do quite a bit of manual work to wire everything together, spread the workloads between them, and it can be very, very challenging. What it might look like is this. You'll deploy a service to one cloud and then update your global DNS, deploy a service to a second cloud, update global DNS, and deploy to a third cloud and update global DNS. Obviously, that requires a whole bunch of tooling or manual work to keep things in sync. In Kubernetes 1.3, we are proud to announce cross-cluster services. So what that means is, in a single cluster, you'll have a federated API master. You talk to that and say, I want this service to be in these three clusters. The API master will simultaneously deploy those services to each of those. And then all of those services will update global DNS about their presence. And what that means is that you don't have to worry about that. So if you then all of a sudden take a cluster down, global DNS can be updated automatically. So much, much easier to run those multiple clusters and multiple services simultaneously. Any questions there before I move on? Okay. The second is around stateful services.
We do have one question.
Yeah.
What DNS providers are supported?
So right now, AWS and Google Cloud are both supported, but it's basically any cloud provider. So the cluster talks to the cloud load balancer that it's in right now. So as long as Kubernetes can use type load balancer as the service endpoint, and Kubernetes knows how to communicate with that cloud because that cloud provider is present, then it will work properly. And what you do is just round robin DNS across all of them, like with your global load balancer. Are there a particular one that you were looking for?
Nope.
Okay. So yeah, so this is really one of those upstream ones. If you want to tackle it, if you have a load balancer that you want, please help us with the in cloud provider and other things like that, just to get it supported in core Kubernetes, and then it's automatically picked up into the federation. The second is around stateful applications. So if you have something like a canonical example is a key value store like Zookeeper, it typically requires the following things: persistent disks that are automatically configured, stable host names so that after a reboot, it gets the same host name it wanted back, lifecycle actions like when you first started, can it take an init step where it elects a leader or joins a quorum or things like that. And finally, identities in a group. So if you have 1, 2, 3, 4, 5, they are unique. And if number 4 dies, number 4 will be restarted, not number 6. Unfortunately, natively, containers provide none of these, which is not awesome. But with the brand new code name, PetSet API, you can now provide all of them natively in Kubernetes. So to walk you through what this might look like, let's say I was starting MySQL. The first thing I would do is create a MySQL PetSet. Again, PetSet is a code name. We're working to finalize the name right now. Inside that PetSet, you would create, it would go and create 3 replicas, for example, of MySQL. Each one will have a init container that gets started, and that init container will take whatever action. Maybe it checks the disk, maybe it empties a directory, maybe it joins a quorum, whatever it might be. And then it will also automatically, it will kill that init container after it's been done running, or it'll just terminate itself, and then it will also provision a disk. And like I said, MySQL is smart, or excuse me, PetSet is smart enough to restart it. So let's say number 1 in that dies, MySQL will, PetSet will restart number 1. It won't go and restart number 3. So, any questions about that? Okay.
Doesn't look like it.
Okay, so then finally we have what's called Minikube. A problem today is how do you develop locally? Again, it's pretty trivial to spin up a cluster in the cloud if you're already on AWS, Google Cloud, Rackspace, Azure. They're all supported cloud providers. You can spin them up, but sometimes you just want a local development tool. And that's where we have built Minikube. So with that, let me just dive into some demos. Can you all see this? Is this too small?
It's pretty small. That's good.
So Minikube actually starts up a VM. All you do is do Minikube start, and it gets going. I won't do that because it does start a full VM. So it takes about 3 or 4 minutes to get going just the first time. But once you've started, it is off and running, and you can do all kinds of things like get pods, Minikube control, get nodes, and this is all running here. It got a single VM there, and it has this really cool feature called you have a full local UI running locally. so I'm not going to show this because unfortunately I'm running on my machine at work and it's got a weird proxy on it. So, but this is basically it here, and I can do a full deploy of a containerized app. I can enter a full, add a YAML or JSON file. I can do all kinds of app details here. And just to show you, this is real live Kubernetes. I'm going to go straight to the command line, and let's do kube control. Let's do expose. So I'm going to start up something here. It says run hello node, and it's image, Aronchick. This is a public thing. All it does is a very simple, what do you call it? Hello node. Yes, thank you. Very simple website hosted at 8080, and I'm going to expose it. Oops, sorry. Delete service. Hello node. And there we go. So I'm going to do this and run it. Sorry. Delete. All right. All right, so off we go. And it's going to create it. And inside that, I'm going to say kube control get pods. And it is creating those pods based on what I requested. It created a replication controller. Oops. Accept. And it created a deployment. You can see it all there. And then when I want to create a service, oops, expose. Or did I let go? Oh, no. Oh, I know. Sorry. Oop. All right. Well, you get the idea. My thing went away. All right. But then if I want to do a, what do you call it? Oh, there it is. So, all right. Well, you get the idea. And if I refresh this, you can see here that the deployment has been created, the replica sets, so on and so forth. I can drill in. And this is all my local, deployment running properly with proper replica sets, with the proper deployments. And I can do all kinds of things, rolling updates and service exposure and things like that. So far, so good.
Not seeing any questions.
Okay. Going back then.
Awesome. In fact, we have an update saying awesome. Thank you.
All right. So, and that's Minikube. So you can get that downloaded, installing very, very quickly without any problems, and let you do all kinds of debugging. So what's next? Kubernetes 1.4, which is coming in September. So again, we're on an extremely short cadence, and we're quite proud of that. We try and release every 3 months, and so I can tell you right now that Kubernetes 1.4 is coming in September, and Kubernetes 1.5 will be hopefully 3 months after that, and Kubernetes 1.6 and 7 and 8. Again, our goal is to be very, very religious about keeping our schedule tight, releasing quickly, responding to what your needs are. In Kubernetes 1.4, we hope to accomplish the set of the following. Full cluster federation. So whereas previously we just had services, now we want to provide a distributed replica set, a global load balancer, so that it's not just services, it's actually workloads that are running. The second is around granular permissions for clusters. So we already have integrated identity and authentication management, and we want to give people the ability to have much more granular permissions so that you can give someone developer-only access, so they could, roll out their application but not have any control over the cluster. We're going to have a bunch of default simplified applications. So if you want to run a MySQL, Postgres, Zookeeper, they will be, single command installations for default, much in the same way you do today with your package manager. And then universal setup. We're doing a bunch of work to make it much easier to understand exactly what the steps are around setting up a Kubernetes cluster and reduce those steps a lot. So a lot of things will be in the box by default, certainly changeable, but it'll be much, much easier to get going. And with that, I wanted to give plenty of time for questions. As I mentioned, Kubernetes is open, open community, open design, open source, open to ideas. Please reach out at any of these places. We would love to hear you. Reach out to me at Google, at Twitter, you name it. Yeah, please just let me know.
2 questions for starters. Is there a doc about integration LDAP as off backend?
Yeah, that should already be live. If it's not, please send me a note. Or just send me a note anyway, and I'll find it for you and send it over to you.
Okay, and the second question that we have already is thoughts about directing service traffic to the local data center. Do you have any?
Can you say a little bit more about that? Is it what you're saying is you want a
in a federated setup?
Ah, got it. So yeah, what you would do there is so we don't have in the overall federation scheme. We do want to keep the traffic locally, and I believe that feature made it in, which is to say, let's say you have 2 services. Let me try and restate to make sure I understand what you're saying. You have 2 services that span 2 different clusters for the sake of argument. Call it front end and back end for the sake of argument. What you're looking to do is have your front end try and stay in the same cluster when it talks to that back end. Only if that backend isn't available in the cluster will it redirect to the other cluster. Is that roughly what you're looking for?
Exactly.
Okay. So to the best of my knowledge, that feature did make it in. I need to double check, but to the best of my knowledge, that feature did make it in. If it didn't, it's certainly coming in 1.4. We at Google run that way. It's very, very important that people need to be able to direct the traffic locally.
There is a question about the benefits around Docker alternatives like Rocket. Are there benefits? Are there drawbacks? What is there?
Yeah, so I don't want to kind of comment on that. Only in that, like, different workloads have different requirements, and some folks want to use a daemon, some folks want to use systemd. There's different ways of separating it. There's different APIs. And as Kubernetes, we want to be very neutral and allow people to choose the runtimes that make sense for their particular workload. So in that capacity, we just want to support whatever is out there and support customers. I would highly encourage you to go and talk to the CoreOS people or the Docker people, and they'll probably have a better answer for it than I will.
We've got another one, which is, if a pod is restarted, it will run on will it run on the previous machine? If it's not, how is that handled with local storage? I think it's a clean storage, so I can't find old data. So do you re-provision storage each time?
Yeah, so that's an excellent point. I don't believe data gravity made it into the feature. To the best of my knowledge, I think Kubernetes does try and restart in place. But in the spirit of pets versus cattle and best practices, I'd love to hear more, and we could talk about it offline. Please email me about what you're trying to do. A best practice is do whatever you're doing with your VM today. So if you don't care about your VM, when your VM goes away, you recopy the data down as part of a startup script, or or maybe you do care that your VM, you want that maintained, and every time it comes up, you mount in a share, or whatever that might be. That's the pattern that I would reuse with however you're doing containers. That's a long way of saying, please do not, at least for now, rely on Kubernetes to only restart your container on the same machine it was killed on, because it could have been killed because that machine was out of memory and it needs to be scheduled to a new place. So that's just not a good situation to be in.
Another question has popped up. You mentioned a global load balancer in 1.4. Would that be an alternative to GCE's HTTP load balancer and an AWS ELB?
I would probably, as a best practice, use them in conjunction. A lot of it depends on what your latency and overall requirements are when it comes to that. You can very trivially spread across all the nodes, just using ELB or even DNS round robin. But generally speaking, you think of this more as a native container native load balancing. There's already native load balancing in Kubernetes by itself. But it does require, using the local IP tables and things like that, which is not ideal. It's also trivial, by the way, to subscribe to one of the Kubernetes Watch APIs and update GCE's HTTP load balancer or Amazon's ELB to directly at your node for those containers. But the direct answer to your question is yes, it could be an alternative, but most people, I believe, would use them in conjunction.
Don't see any further questions, so now's the moment if you want to ask a last question, and then we will wrap up with David. Can you put your slide with all the contact info back up?
Oh yeah, of course.
We'll have you do that. Okay, being written in Go, I assume the load balancer will support HTTP2. Is our global load balancer?
I actually will have to ask bigger brains than I to know exactly what it'll support.
Okay. How does Kubernetes work with Swarm competing, or will Kubernetes extend Swarm? I presume this is the new Swarm in this picture.
Oh, sorry. So the answer is, how will we compete with Swarm? The broad strokes is, we love the folks at Docker, and we're very pleased that they have this great container platform and ecosystem and things like that. We have a different philosophy about how to do orchestration, and we think that we're doing our best to release production-ready things. You'll have to ask the Swarm folks about how flexible and configurable it'll be. There's nothing to say that you couldn't plug in Swarm into Kubernetes and use them in conjunction together. But our goal is to have Kubernetes being an end-to-end production-ready orchestration by itself without any additional add-ons. I would argue they, probably are not. It's not needed to use them both together.
Another question is, can Minikube be used for Kubernetes development?
No, unfortunately. We did get that question recently. It does a raw pull down of the binaries, and to the best of my knowledge.
Yeah, that's where it was, yeah.
So I think it pulls down the binaries right now. So there's no source code and no compilation behind the scenes or anything like that. So unfortunately, no. We would love there to be someone, to have a Docker container or any container that lets you, with a full source tree ready to go, built, ready to do development and things like that. Please contact me and let's talk through exactly what your scenario is. But we want it both to be easy, container level easy to develop on Kubernetes, but then also, potentially make it even easier to download and get going just on your local developer machine.
Awesome. I think we're out of questions at this point.
Cool. And for those of you who didn't want to talk, please email me privately.
Always an option. Julian, do you have words to close?
Yes, thank you very much, David and Sarah, for making this happen. So was really interesting, good talk. Thanks, David. I guess you will share the video later on the official YouTube channel, or I hope so. And we will have this be weekly. This meetup, so feel free to send us some topics or some suggestions you want to have on the show. And if you liked it, please help us to spread the word, and we will see you in 2 weeks. Thank you.